The universe is vast, not just large, but incredibly incomprehensive. Within it are hundreds of billions of galaxies, each containing hundreds of billions of stars, many of them older than our sun. Around a significant number of these stars, planets exist, some rocky, some temperate, some potentially capable of supporting life. By every reasonable estimate, life should not be rare. Intelligent life, while more complex, should still have emerged many times over the history of the universe. And yet, the universe appears silent. There's no signal, no probes, no evidence of civilization spanning the stars. In 1950, physicist Enrico Fermi asked a simple question: where is everyone? To understand why this question is so unsettling, we need to attempt an estimate. In 1961, astronomer Frank Drake proposed a way to calculate how many technological civilizations might exist in our galaxy. It was not a claim, only a framework. The Milky Way contains between 100 and 400 billion stars. We now know that planets are not rare. Most stars appear to host them, and a measurable fraction orbit within a narrow band where liquid water can remain stable. If life emerges whenever conditions allow, then simple organisms may be widespread. Given sufficient time, evolution does not remain simple. Even if only a small percentage of intelligent species develop technology capable of signaling across space, the arithmetic becomes difficult to ignore. Conservative assumptions still produce thousands, perhaps millions of civilizations that should be detectable within our galaxy alone. And yet, as we look out into the cosmos, we see nothing. For more than half a century, humanity has been listening. Since the 1960s, radio telescopes across the world have scanned the sky, searching for artificial signals from distant civilizations. This effort became known as the Search for Extraterrestrial Intelligence, or SETI. Massive dishes track the slow rotation of the Earth, sweeping their gaze across the galaxy, waiting for something, anything that might indicate we are not alone. Occasionally, something unusual appears. In 1977, a radio telescope in Ohio recorded a powerful burst of radio energy from deep space. The signal lasted 72 seconds. It matched many of the characteristics scientists would expect from an artificial transmission. The astronomer reviewing the data circled the signal and wrote a single word beside it: wow. But the signal was never detected again. Despite decades of continued observation, no confirmed message has ever been received. No probe has entered our solar system. No artifact of another civilization has ever been discovered. The universe is vast, ancient, and statistically it should be full of life. And yet, it still remains silent. One possibility is that the paradox is an illusion. Perhaps intelligent life is not common at all. While planets may be abundant, the conditions required for complex life could be extraordinarily rare. Earth appears to occupy a remarkably fortunate position. Our planet orbits a stable, long-lived star. It lies within the narrow habitable zone where liquid water can persist. A strong magnetic field shields the surface from harmful radiation. Plate tectonics recycle carbon and regulate the climate over geological timescales. And a large moon stabilizes Earth's axial tilt, preventing extreme climate shifts. If you remove any of these factors, then complex life might never emerge. Perhaps the universe is filled with other planets, but very few worlds ever become anything like what we have here on Earth. Another possibility is more unsettling. Perhaps life is not rare. Perhaps intelligence is not rare. Perhaps technological civilizations emerge across the universe, but they do not last. Somewhere between lifeless matter and a civilization capable of spanning the stars, there may be a barrier, a threshold almost none survive. This idea is known as the Great Filter. It could lie behind us. The emergence of life itself may be extraordinarily unlikely, or the leap from simple cells to complex organisms, or the jump from intelligence to advanced technology. If so, we are rare. But the filter may also lie ahead of us. Civilizations may routinely discover technologies powerful enough to destroy themselves. Nuclear war, environmental collapse, artificial intelligence. In that case, the silence is not mysterious. For us, it is inescapable. Another possibility is far more unsettling. It is known as the dark forest hypothesis. Perhaps the universe is not silent. Perhaps civilizations are simply choosing to remain quiet. In a dark forest, every civilization is both hunter and prey. No one knows who else may be watching, or what they may be capable of. Revealing your location could be the last mistake a civilization ever makes. If this is true, the silence of the universe may not be mysterious at all. It may be deliberate. And in that case, the silence might be the best thing that has ever happened to us. Because while humanity continues to call out to the cosmos, it is entirely possible that not everyone out there is friendly. The universe is unimaginably vast, filled with hundreds of billions of galaxies and trillions of planets. By all reasonable estimates, life should not be rare, and yet the universe appears silent. Perhaps life itself is extraordinarily rare. Perhaps civilizations rarely survive long enough to reach the stars. Or perhaps they are out there, quietly hiding in the darkness. If the universe should be full of life, and yet we find none, then either we are unimaginably rare or unimaginably early. And somewhere beyond our understanding, the answer still waits. Where is everyone?